Okay, in this video what we're going to talk about is we are going to talk about the beginnings of exponential and logarithmic modeling. So specifically we're going to look at graphing, and then we are going to look at application problems and how some of these exponential and logarithmic ideas are going to filter into our everyday problems. So to start with, we need to be able to look at what is exponential versus logarithmic. Okay. Well, to do that, just quickly we need to recall some of the basic functions that we have, those being linear and quadratic. Remember, when we talk about linear, we're talking about a power of 1. Okay, your graph is a straight line. So we have 4 different ways that this line can occur. First, we have what's called your increasing line. Okay. Then we have your decreasing line. Okay. We also have your vertical line. So that's the one that is straight up and down. So this is vertical. And we have horizontal. Okay. We then moved into quadratic. Quadratic again is the power of 2. It's where we have 2 solutions, and the graph here is a parabola in shape. So if you remember your parabolas, we have 2 versions of them. We either have that it opens up, in other words, the arrows point towards the top of your page. This means positive. Or we have your parabola where the arrows point down to the bottom of your page, and this would be negative. Okay, so here negative would be that it opens down, whereas positive would mean that we open up. Okay. Exponentials and logs are a little bit different. When we talk about exponential, we are talking about where your power is the variable. Okay, so with quadratics and linears, your variable is a big part of the equation, and any powers you may have would be digits or numbers. But with your exponentials, now my power is going to be where you find the variable, and everything else about the equation is going to be a digit or a number. The other thing that you need to know is that when we're talking about exponentials, the graphs will only ever intersect the y-axis. So when we're talking about a positive, okay, we're talking about intersecting on the positive y-axis. Okay, so this here would be a positive graph. Okay. So I want to look at a couple examples just so you can see how this will work. And with most of your exponential or logarithmic functions, to graph it, the easiest and fastest thing to do is to create yourself an XY table. You should recall that the easiest values go from -2 to a +2. Okay? So for most cases, that's going to be the easiest snapshot for you to look at, is that the easiest values are going to go from -2 to +2. So I'm going to create myself a table where I have x, and then my y was 2 to the x. And when I do this, I am keeping in mind that I want to use my x values from -2 to +2. So I'm going to kind of set that up. So I've got -2, -1, 0, 1, and 2. And this should be enough to give me a good sense or a good idea of what my graph is looking like. So we're really just looking at the snapshot of values that fall right here around your origin point. Well, again, when we're looking at these, we have to plug the x value in. So here, this becomes 2 to the negative 2. And then of course you could use your calculator, or you could remember your exponent rules say if you have a negative power, you flip it down to the bottom. So this becomes 1 over 2 squared, which is the same as 1 over 4. Okay. Now here I need to do it again. So I have 2 to the negative first. Again, this is a negative in my exponent, so I have to flip it, which means I flip it to the bottom. So this becomes 2 to the first, which is just simply 1/2. Then I have 2 to the 0 power. And in terms of exponents, that's a rule. Anything raised to the 0 power will always come out as 1. Okay? So that's just a rule that you need to know. And you can double check it in your calculator by doing 2, using your exponential function and going to raising it to the 0 power. So for example, on this particular calculator, notice I have my power button right here where it shows x and then to the power. So for me, on my calculator, if I were to do 2 to the 0, I would type in the 2. I would have to hit my power button. Notice it gives me the power, input that 0, and hit enter. And it gives me 1 as an answer. Now, some calculators, obviously, that are not the 36 Pro are going to do things a little different. So for some of them, you might need to look for a button that says y to the x, or you may have to look for what's called the little hat button that looks like a caret. Both of those are other ways that different calculators represent a power. Okay. Now we have 2 to the first, which we all know is 2, and then we have 2 squared, which gives you 4. So what you should notice here is that if you have a whole number raised to a variable power, then your negative values will give you fraction results. So if we know that about whole numbers, you can make a guess that that would mean that if this was a fraction, then my negative values would give me a whole number as a result. Okay, so that's one thing to keep in mind. Now here, all I have to do is graph my coordinate points. So I would start with the easy ones first, meaning I would start here with the whole numbers. And I would graph these before worrying about graphing the fractions. So a good place to start is right here in the middle. When x is 0, y is 1. So that's right here, crossing my y-intercept. And because I'm crossing that y-axis value here, it means that I have most likely created my table correctly. I then have when x is 1, y is 2. So that's 1, 2 here. And then I have when x is 2, y is 4. 1, 2, 3, 4. Now on the other side, I have at negative 1, my y is at 1/2, so that's roughly a half. And then at negative 2, I'm down at a quarter. So that's kind of getting closer to the axis. And now to finish it off, all you have to do is connect your dots. So here, you're going to draw very close to your axis line, and then you are slowly going to lift your line up through your coordinate points, and then it's going to shoot up through the roof. Okay, and so that would be your first graph. So let's look at the next one. So notice here that we have an equation up here in my power where we have x minus 1. So we're still going to do the same x, y table. The only difference is, in this case, we're going to have a little bit more work that we have to do with our values. I'm still going to pick the same -2, -1, 0, 1, and 2. And this time I have to plug this in. So I have -2, so this becomes 4 to the -2 minus 1. You need to do the math inside the power first before you reduce and simplify. So here this becomes 4 to the -3. My exponent rule says I need to flip my reciprocal. So this becomes 1 over 4 to the 3rd. And 4 to the 3rd is 64. So this is 1 over 64. Now I need to repeat the process. So 4, this is -1 minus 1. So this is going to be the same as 4 to the -2. I need to make it positive, so 1 over 4 squared, and 4 squared is 16. Here I have 4 to the 0 minus 1. So this is the same as 4 to the -1st. Again, make it positive. 1 over 4 to the 1st is the same as 1/4. Next, I have 4 to the 1st minus 1. This is the same as 4 to the 0, which gives you 1 as an answer. And then I have 4 to the 2 minus 1, which is the same as 4 to the 1st, which gives you 4 as an answer. Now, one thing you need to remember, if you need to make it easy, all of these are coordinate points. So this is -2, 1 over 64. This is -1 and 1 over 16. This is 0 and 1 over 4. This is the point 1, 1. And this is the point 2, 4. So now we're going to go ahead and graph those. Again, I would start with the easy ones. So I would start here with my whole numbers. And I would do these first. So I have the point 1, 1, so over 1, up 1. And then I have the point 2, 4, so 1, 2, 1, 2, 3, 4. And then I'm going to start working my fractions. So I'm going to go to my next one. I have the point 0, 1, 4, so this is really close to my axis line. Then I have the point -1, 1/16, so again I'm even closer. And then -2 and 1/64, so again I'm even closer. So in order to graph this one, you're again going to start basically traveling your axis line pretty close to it. And then we're slowly going to travel through our points, and then we're going to shoot up very quickly. Okay. So again, notice my large term was a whole number, which meant my negatives here were the fractions. Okay. Now, another interesting term that we have when dealing with exponents is the e value. E has its own special place on the calculator. So again, if we look at the calculator notice I have this e to the square button right here. So this would be the button that I would push if I wanted to evaluate with my e term. Okay. Other calculators show things like e to the x. You could see e to the y. Some calculators just show e. And so it depends on kind of the calculator you have, but you need to make sure that you find this value. Now e itself has a number, it is a term, and it does go on forever. And so in order to actually create this xy table, we have to be able to use that e function. So here again, I'm still going to create x, and I'm still going to do negative e to the 1/4 x. And I'm still going to use -2, -1, 0, 1, and 2. And we're going to go ahead and set this up. So here again, we're going to have negative e to the 1/4 times a -2. And then in this case, you would go ahead and use your calculator in order to do the math. So, showing you mine. Okay. So first I have this negative. So down here where you've got the parentheses around the negative sign, that means negative. Okay. Some calculators have this button, others don't. If your calculator does not have one of these, then you would use the subtraction button here. But mine has it, so we have to use it. So this is negative, and then it is e. So I'm going to hit my e button. Notice I get an e on the screen. And then I'm going to open a parentheses because I have to do this multiplication here, 1/4 times -2. So I'm going to just go ahead and let my calculator do that work for me. 1/4 is the same as 0.25 times a -2 and close that parentheses. What you're going to notice is that you're going to get a decimal here, and that's okay. So we're going to use that decimal. So it was -0.6, and I would go ahead and round it. So -0.61. Okay. Rounding to the hundredths place is going to get you a fairly accurate answer. And now we have to do it again. So we have a negative e to the 1/4 times a -1. So again, we're going to come into the calculator. We're going to use the negative sign. We're going to hit the e button. We're going to open a parentheses. And if you don't remember that it's supposed to be 0.25, you would just simply open a second parentheses and do 1 divided by 4, close it, and then multiply by the -1 and close it, and that'll give you your answer. And that'll be the same answer as if you had used the decimal value. So here again we'll round, so this becomes -0.78. Again we have negative e to the 1/4 times 0. Well, this one you could do in your head. 1/4 times 0 is 0. E to the 0 is 1. Apply your negative. Gives you a -1. Now we have negative e to the 1/4 times 1. So again, we use our calculator. Hit a negative. Hit your e button. Open your parentheses. And we're going to do 1/4 times our 1. And we get -1.28. And then last we have that negative e to the 1/4 times 2. So last, negative e, open that parentheses, 0.25 times 2, close it, and we get -1.65. So we can actually graph all of these. So we have the coordinate points 0, -1. So 0, -1. So notice my term was negative, so I'm now on the negative side of my axis. Then it's just a matter of graph and go. So over at 1, I'm down at negative 1.28. So this is negative 1 and a little bit further. At 2, I'm down at 1.65. So I'm over at 2 and I'm down a little bit further. Okay. At negative 1, I'm at negative 0.78. So negative 1, I'm going to be at 0.78. And then at negative 2, I'm at the 0.61. Okay. So what you should notice about this one is that this graph is going to be a lot more wide. Again, you're going to start and travel kind of along your axis till you kind of get to your first point, and then you're going to kind of travel through your points, and then we're going to come out kind of in this direction. Okay. So it's a lot broader. Part of that has to do with the fact that this is a fraction in the power as well as the negative sign, so that kind of broadens out your graph a little bit. Now we can also look at applications. So here we need to model the exponential function to solve our application. Jeremy deposits $6,500 into an account that is compounded continuously at 4.2%. Determine how much in the account after 12 years. And notice in this one it's telling you what formula to use. So if you remember, compounding continuously uses the PERT formula. So here we're going to do just that. So we have A equals PE, raise it to the RT. And what do we know? Well, we know that P is going to be 6,500. We know my rate has to be a decimal, so it is 4.2%. Divide that number by 100, gives you the decimal 0.042. And then my time is 12 years. So I need to plug this in. A is equal to 6,500 e to the 0.042 times 12. So again, you would use your calculator here, and I would do this one in 2 steps. So if we look at it, I have E, so I'm going to hit my E button, open a parentheses, 0.042 times 12, close that parenthesis and hit enter. Now this value right here is going to be held in your calculator as a saved answer. So I can simply hit the multiplication. So notice it says answer time. So ANS stands for the last answer in your calculator. And I want to multiply this by 6,500. And hit enter. So I have $10,759.64. Now the biggest thing you have to remember when we're talking about money is money only goes to the hundredths. So you always need to make sure that you round to the hundredth spot. So we have $10,759.64. Okay. And that would be your answer. So this right here is what we were looking for. Okay. So let's look at another type. Here, the current population of a town in California is modeled by the following function. And notice I'm giving you the function. So if the problem gives you a function, you should use it. And here it says where x is the number of years after 2012. The question wants to know what the population in the town will be in the year 2030. So the first thing we have to do is we have to figure out what x equals. Well, x is the number of years after 2012. So 2030 minus 2012 has to equal the number of years that we are looking at. And in this case, that would be 18. Once you know that, the rest is fairly simple. We have to plug in our number of years into the problem that we've been given. So this was 1066.058 times 1.0434, and we're raising this to the 18. So again, you're going to want to work this in steps. So the first step that you're going to want to do is you are going to want to do your parentheses. So you want to do 1.0434. We're going to raise this to the 18th power. So again, remember that's your, for me it's my power button here. For you it might be that hat button or y to the x. And you're going to hit enter. Again, we're going to save that value as our answer and just simply hit the times, and we're going to put in the next number. So 1.066.058 and hit enter, and we get 2290.31. Okay. So here this comes out to being that 2290.32 if you want to round. But the other thing you need to keep in mind is you cannot have a partial person. Therefore, the town will have 2290 people. Okay. So when you're working with populations, you do need to keep a little bit of logic in mind, and that for the most part, you don't have part of a person. And so when we're talking about population of a town, we are talking about actual people, therefore the whole numbers. We also don't usually round up a person. You generally round down to your whole number. Okay. Now the last exponential example I wanted to show is this one. And it says a new virus has broken out in isolated parts of Africa and is spreading exponentially through tribal villages. The growth of this new virus can be modeled using the following formula, where P stands for the number of people in a village and D stands for the number of days since the virus first appeared. According to this equation, how many people in a tribe of 300 will be infected after 5 days? So we've got some information. First, we know P is equal to the number of people, which our problem said was 300. We also know that D is equal to the number of days, which our problem said 5. If you notice, I have 3 variables, V, P, and D. 2 of them have been filled in. Therefore, I have to simply solve for the missing one, which is V. So here I've got that V is equal to my 300 times 1 minus E to the negative 0.18 times 5. Okay. So again, I would work this problem kind of slow, and I would work from the inside out. So we're going to start here with the E. So I have my E, and I've raised it to the negative 0.18 times 5. Close your parenthesis and hit enter. Then I want to do 1 minus, And I want to use this answer here. So notice above my negative sign I have the word answer. So I'm going to hit second and then my negative sign. The ANS shows up, which means I'm going to pull this answer through, and then I'm going to hit enter. And then I want to take this and I want to multiply this by 300. And when I do that, I get 178.03. So this is 178.03. And so here, when we're talking about how many people are affected after 5 days, well, you would have to say that there are roughly 178 people infected. Okay. So that is exponentials. Now the other half, or its partner, is logarithmic functions. Logarithmic functions use log or ln. ln stands for natural log. And these will cross your graph only through the x-axis. Okay. So one example that you may see or that you would have to work with is the following, where you need to create a scatter plot, okay, for the data in each table. And then you need to be able to determine, based on that, if you have linear, quadratic, exponential, or logarithmic. Okay. So the first thing that we have to do is we have to graph these points here. That's what they mean by scatter plot. So we are going to graph those points and see what happens. So first I have the point 0, 0. So I'm going to graph that down. Then I have the point 1, negative 3. So I'm going to go over 1, down 3. And then I have negative 1, negative 3. So negative 1, down 3. 1, 2, 3. 1, 2, 3. And then I have the point 2 and negative 12. So notice that's going to kind of be off my graph. So I'm going to connect my scatter here so that I can see the picture. And in looking at this, you should be able to tell that this is a parabola in shape, which means this one is quadratic. Okay, pretty simple. So let's look at another one. So here, again, I need to graph these points in order to see what's going on. So I have the point 1, 0, so over 1, 0. Then I have the point 2, 1, so over 2, up 1. Then I have the point 1/2, negative 1. So I'm over a half, but I'm down at negative 1. Then I have the point 4, 2, so 1, 2, 3, 4, 1, 2. And last I have the point 1/4, negative 2. Okay, so if you look at these, again, you can see that I'm tracing essentially my y-axis and then going through my points. If you look, this graph here is crossing through my x-axis, and so based on this example up here, we would call that logarithmic. Okay, so here, this one is a logarithmic function or a logarithmic graph. Okay.